Good. Cool. All right, so good. All right, and we are live. What is up, everybody? We are here for live stream, Data on Kubernetes Community live stream number 129. We're kind of in this limbo mode where we've been saying 129, 130. It doesn't matter. What the point is that it's high quality content coming to you as always. We will be having, of course, if you haven't signed up for the DoK, virtual DoK day that we'll be doing on May 16th, I will drop the link here so you can do that. You'll see the whole schedule on there, and then you'll be able to register through the CNCF website. It's absolutely free. You just got to add it to your KubeCon registration. So you definitely want to check out all the stuff going on there. In the meantime, as usual, we have high quality content as we always do. And that brings me to our guest who is no stranger to our community. Barak works at a really, really cool startup called Ionir. Barak, for the people who don't know you, what should they know about you? How would you like to introduce yourself?
First of all, hi, Bart. Hi, everyone.
Hey.
I think in the past, my entire career was around, cloud and data center and IT technologies. And I think, that's my specialty, customer roles, working with customers on solving complex problems in their infrastructure with technology. I think that's what excites me. And this is, what I've been doing for the past almost 20 years. So yeah, that's my background and specialty, let's say, in one sentence.
That's good. And a thing that's very important to our community, which you absolutely are aligned with, is putting the end user at the center. It's one thing to be in a lab and to be imagining how this technology is going to do this or that. When you actually have to sit down with somebody and troubleshoot, it totally changes. And I think that, what do you think that, just as a starter question, what are some of the things that people could improve when it comes to being more empathetic with end users, when it comes to being customer facing? What are some of your techniques that you have used that have worked?
I think that in most cases, you see that, in the industry, let's say, so sometimes, people are approaching with the technology first and not with, trying to understand. So usually, in customers meetings or even partners or anyone in the industry, it doesn't have to be a customer even, you always ask questions and listen and try to, learn from them. So I think that the top thing for everyone, and I think it's very descriptive for the Kubernetes community in general, the learning aspect, the learning from each other, the learning, the exploration and so on. This is what I like in this world, to be honest, because not everything is said by huge market trend vendors that are saying this is how you have to do things, which has been describing the old world, let's say. But I think that the Kubernetes space in general is a great ground for innovation and learning, and this is the top thing that this community brings up.
Good, solid answer. Really liked it. And like you said, asking questions, being willing to learn new things and explore new things. That being said, today we're going to be talking about cloud and database operations. What does that mean exactly?
Correct. So I really wanted to do something that is at least has few values in means of who's listening to this session. I really wanted to start with kind of the basics of as we all probably know, databases is one of the first class citizens to run a data on Kubernetes. It's the go-to workloads, let's say, as day one value for Kubernetes. But I really wanted to have some sort of a talk that walks through the basics of how you address data and how you manage those layers inside of Kubernetes, kind of the infrastructure look of things, and then travel upwards in the technology stack, let's say, to how databases are done, in the cloud in general, and what's the problem that most customers try to solve with that approach, and how at least we see the market transitioning from some services that specifically maybe databases as well, but in general movement from let's say cloud lock-in vendors kind of solutions towards Kubernetes that allows you this breadth of technology and multi-cloud and the other benefits that Kubernetes actually brings to customers. So I wanted to touch also on that aspect as well to see what's the trends and a little bit share with what I've heard from our customers and some of the the partners that we talk throughout this field as well. And some if there are any questions I guess you're gonna call them out, so feel free to stop me at any point. This is not like a I don't have my speech lined up. This is just, I'm trying to share my knowledge and share my experience and, observations. More than happy if somebody disagrees and we can, create a conversation out of it. It's always a good ground for, for learning. And that's about it.
No, that sounds great.
Okay.
And having had you as a speaker before, very practical, down to earth, and you're a great teacher. So like I said, folks, if you've got questions, you can leave them on YouTube. You can also take the conversation to Slack. Barak is very easy to talk to and very open-minded. So that being said, if you want to start sharing your screen, we can take it from there.
Sure.
Okay.
I'm going to share my screen and let's see if it works well for the first time. Yeah, usually it's a dual screen and Zoom is not the best friends, but I think
got it.
That works well. You know what? I'll try. I'll even try something. No, I'll just do it like this. I wanted to do. There's a feature in Zoom that you can have your video like embedded in the presentation, but I just thought it's probably going to crash my laptop. So
that's okay. No
yeah, I decided to let it go. So again, hi everyone. This is me, Barak here, and as Bart mentioned. I'm going to a little bit talk about data and databases in Kubernetes and in cloud in general, and a little bit how it looks in the Kubernetes, ecosystem. So let's start. In general, so as I mentioned before, I want to break down a little bit of, how data is represented specifically in Kubernetes clusters. I'm going to touch, a little bit about, the CSI driver flows and workflow. Let's say how data is actually requested and served, or you can look at it as provisioned and mounted on Kubernetes or for Kubernetes pods, all the way from the the application level to the underlying infrastructure. So I'm going to touch briefly about that process. We're going to talk about different data services that actually data related workloads need from the infrastructure and why we use data and what is the benefit of presenting data to pods. And we're going to move briefly up the up the chain, talk a little bit about how distributed systems or how consensus is met in different distributed models. I didn't want to make a talk specifically about this, so I'm going to present some concepts, some buzzwords, some things that to keep in mind when you think about moving your databases from whatever to Kubernetes, or in general, data related workloads to distributed systems like Kubernetes. We're going to talk about the alternatives that we have, let's say that we have right now in means of, I'm going to move this out here, in means of you as a customer or whatever as a cloud engineer, what's the options, and a little bit about the trend that we're seeing in means of the platform for databases. We'll talk about it a bit, and some scaling options and ideas that I have pulled up together at the last slide about aspects of things of operating that in the cloud itself. So I'm gonna jump right into it. So that was a big intro. So for the first part of it, if you remember, I wanted to briefly touch about how we are or how a pod, and this is like a very let's say elaborated slide. So I'm going to try to walk you through this so I understand the flow. But in essence, the high level, the upper side is the application side. This is, for example, Postgres as a representative for a workload that is run inside of a pod, right? And this pod is just the application level of things. And we're going to walk through, the breakdown or the abstraction that Kubernetes actually make together with the CSI drivers and plugins, all the way to what actually is, let's say, the backend or the infrastructure for that specific data point. So I'm going to walk this through. Try to stay with me. If something is not clear, let me know. I'll have another. I have another hidden slide that makes it a little bit more flow wise, but in general, we have our Postgres pod, which is actually, you download the Docker image or from Docker Hub or whatever your repo is. And that pod is actually, that content is actually immutable. It's just a registry. It's come from the registry. This is just the pod that runs the service of Postgres. And then actually, inside of that pod, you can see, the mount points. This is like the basic of Linux of how you, mount devices to a specific, we can call it like operating system, but this is abstracted like we do in virtualization, but the same for Kubernetes. So the pod or the Postgres doesn't really know that it runs inside of Kubernetes or what other, operating system that is running it. You have the file system level. This is like the high level connectivity that the app does. So it just writes to files, for example, and creates files and so on and so on. And then if you go one layer below that, you have the devices that are mounted inside to that pod. And these are, in general, the where the data is actually persistent. So this is how we redirect data out of the, the ephemeral content of the pod, and we redirect that data using that mount to a different location. And this location is provided by, PVC, and I don't want to make it like the basic, what is a PVC and what is a PV, so I assume most people know about it, but if not, there's a lot of information out there about specifically what each component is or which each resource is. But in general, the PVC is something that is representing the request for the storage, let's say, or the request for the data, and that is satisfied by a PV. And once these two components are aligned, the request and the system says that this is what answers that specific request, you've got a status that is called like a bound. So a PV is bound to a PVC, and then actually the system is able to start working and writing to that PV. So all up until this level, everything is like abstracted and completely in the world of Kubernetes, right? So everything is a resource within Kubernetes. And what actually is interesting as part of this CSI revolution that happened a few years back is the fact that we can have components that satisfy this PV with something that is completely abstracted as well. So for example, at this level, once the PVC is represented and the system needs to provide a PV to answer to it, there's a certain stages and steps and processes that are actually happening within the Kubernetes clusters and have like two phases, right? So one phase is towards the PVC and towards the abstraction level, and the other phase or the other way is towards the physical world, let's say, or the virtualized world, depends, where you run. And that creates that resource to be satisfied. So all the way to the PV, it's all like abstracted. And then in the backend, what you're getting is a CSI node plugin that, talks to your storage vendor, for example, your external provisioner, and that attaches that PV object to something that is, on the physical world, a specific volume. It can be, an EBS volume. It can be, whatever storage vendor that you work in your environment. And in the back end, outside of this, all the way down Apple T here, this is in the Kubernetes world, and this is the storage world. So the storage world, which is like external to the Kubernetes abstraction, you have multiple data services or data specific tasks that are happening on the storage level, which can be like deduplication, replication, making sure that the storage is highly available, or sharing the volume between multiple nodes. For example, if you're not running any like shared storage solution, every PV that you create can be satisfied by the local node file system, for example, and then you're just using host DIRs or empty DIRs or whatever you configure in your environment. You're using that only from that specific node. And then if your pod needs to be rescheduled, or you have a HA scenario or whatever, then this data is ephemeral. And this is exactly what data on Kubernetes or the whole world of CSI and Kubernetes native data or storage, whatever you want to call it. There's a lot of acronyms specifically for that. But in essence, this is the problem that we're trying to solve, and the CSI mechanism is what helps us talk in a specific same language, same request. I don't want to go into the specific details about how you publish a volume and how you mount the volume directly to the pod, but that is like the magic that Kubernetes and CSI does together. But the good thing to understand here is that you have like two systems that are working together throughout this CSI plugin, and they talk together, in a very sleek way. So there's no hiccups. The Kubernetes knows what to ask with the PVCs and storage classes, and the service and the storage size knows how to respond and how to satisfy that request based on all these metrics as well. So that's the flow again from the higher abstraction level, the application. Most of the Kubernetes world, we're talking about the application layer, and we don't necessarily, I don't want to say care, but we don't necessarily understand or plan the underlying infrastructure good enough in most situations. So this is why I wanted to break it down. But in essence, why we need a data platform, why we need a data solution for workloads. This is very similar to what we're doing in VM's world or even bare metal world. Data is what brings you persistency, and you need data helps you to do high availability and backup and restores, and ransomwares, which you hear about it a lot from the from the backup and the recovery industry as well, if you know about those kind of vendors as well. And of course, data is actually, I'm not going to say what's important in the infrastructure, but we see that data is what brings companies the competitive advantage. This is like the sensitive and most valuable asset that most companies have, their data, or the workloads that revolve around data. And we see that running Kubernetes without data is like dancing in two parties. It's a phrase in Hebrew. I don't know if that translates well to English, but dancing in two.
But that's weddings. The nice part of this community is that we get the cultural richness from different languages.
Exactly. So we have a phrase that is called dance in two weddings. It's very hard to do that in a single night, let's say. So
a lot of talent. Yeah.
yeah. So unless they are you're from both sides, or I don't know, never mind. So that's why we want to create Kubernetes as the platform to run all the workloads for the enterprise. And this is why we need data also, or data systems in Kubernetes, to make sure that we have a unified approach and a unified way to look at our infrastructure and to protect it, and to make sure that you have high availability, not only for your Nginx and front ends, but also for your databases in the same way. And this is this is the problem, or this is the challenge that we are trying to solve specifically in Ionir. But there's a lot of vendors again out there in the industry. And in essence, if you look at this, it's like the top things that data can actually help in the Kubernetes platform or the Kubernetes space. And of course, when we talk cloud and we talk multi-cloud and in multi-environments, we see that in a lot of environments with our customers, because Kubernetes is so easy to create or deploy and manage and use and operate, then customers have like multiple environments. They have on-prem and in the cloud, or they have multiple stages and life cycles of environments, from test, prod, or whatever. Sometimes even in an upgrade process, it's far more easier to just create a new Kubernetes clusters and move your workloads instead of actually upgrade and maintenance and run maintenance and run all these day two system level operations on Kubernetes. So we see all these aspects as how data. This is like the field that data actually plays, and and this can give you like benefit that to do it in the infrastructure level rather than implementing in costly and other complex solutions out there. So I mentioned briefly about what it means to run data on top of Kubernetes. So this is like what we expect from let's say a data management platform on top of Kubernetes. It's very, very basic, high level. We got the Kubernetes platform here. In essence, what you need is a solution that aggregates your local physical resources and abstracts them and presents them to the Kubernetes layer. It doesn't matter if it's local storage or external storage. The purpose of a data solution for Kubernetes, it needs to be talking the Kubernetes language. It needs to be distributed. It needs to be easy and fast to consume. You have to be descriptive in the way that you use it. You have to to work with the CSI and the PVC PV model that I mentioned before. And this is what we want to bring into the play. I'm going to take a brief stop on this. I don't know if there's questions, Bart. Do you want to maybe something?
Sorry, that was getting to my mic.
No.
Yeah, the thing is that obviously great layout and really well establishing the scene. When you're meeting with a customer, I mean, how do you go about the process of figuring out exactly where they're at with all this kind of stuff? What kind of, I don't know if you want to call it diagnostics, to make sure that they're prepared to make the decisions that they're going to be making? Just because sometimes these things, I imagine for some folks that we saw in the research report, is that everyone's kind of at a different maturity level when it comes to talking about data on Kubernetes. So what are the things that you seem to encounter there, and how do you approach figuring out exactly where they're at with all this?
Yeah, so in essence, what we see is that there's so many. First of all, I'm going to talk briefly about it later, but we see customers are far more open or understanding the value or the position of Kubernetes as the next generation platform. So we see customers that are actually, willing and interested in solutions to move databases or to move heavy data workloads towards Kubernetes. And this is like the conversation starter that we have in most customers. They either they want to let's say modernize their existing environment, and we see there's another trend here. I didn't plan to talk about it, but I guess it's also relevant to this talk as well. In the world of KubeVirt, where customers we see that a little bit more and more in the market today. Customers that are actually planning or thinking about running virtual machines together with pods or Kubernetes pods or let's say old school pods, if you can say, together on the same platform. And today there's I don't want to call it like an open source, but there are different vendors that are running this in enterprise and commercial solutions as well, like KubeVirt, that actually allows you to run VMs together with pods on the same Kubernetes platform. And that is a bit of a shift in how customers are looking at Kubernetes for understanding, okay, wow, now I can run all of my workloads on top of Kubernetes and get the same benefits for VMs on top of Kubernetes. And then really the storage and the data conversation uplift from ephemeral usages and stuff like that to more databases and transactional loads kind of workloads. And this is really pushing customers to explore running data on Kubernetes. The other thing is cost and operation costs and simplifying that as well. We see customers that are really interested in kind of a hybrid approach, whereas they're running their let's say primary databases on instances or VMs, but their test and dev environments, they want to run that in something that is less costly and easier to configure and run. And then they're looking for Kubernetes as they're probably running whatever tests and devs already in Kubernetes, and they want to present that as part of the platform as well. So there's a lot of like work streams, or you can call it like tailwinds for data on Kubernetes. Specifically, when we talk about databases, then this is like the first class citizen. As I said, customers are going to that first. because it makes sense also to bring your application or your front end closer with your back end in means of operation, in means of technology stack, in means of managing this in all in one platform. There's a lot of power in it.
Got it. Good. Like you said, there are some things you're going to be mentioning a little bit later on, so we can kind of connect that a little bit later.
Yeah, perfect. So that's the storage side, data side. I want to, as I mentioned, move a little bit higher in means of the conversational technology level, move from the infrastructure more to the application, or the application connectivity, let's say. So there's a few concepts here. I just want to make sure that everybody is knowing this, and this is also important to understand when you design distributed systems and data in specific, and databases in more even specific way. Then we're talking a few things. I'm going to walk briefly around this just to introduce this. First of all, we have something that is called like the CAP theorem, the CAP, which talks about like the three major concerns or the three major let's say characteristics of your data or your data approach services. In high level, it means about consistency, availability, and partitioning. So consistency is how data is consistent or kept consistent. Availability is what happens, if some connectivity is broken, or let's say how you address high availability in means of nodes running in your cluster. And partitioning is how you operate in a network failure, kind of a split brain, or kind of that kind of connectivity. And the concept is that you can only pick kind of two. There's no perfect solution that operates, in a utopian world where you can have consistency and availability and partitioning aware, let's say, solution others. So you have to pick two. And depends on how you pick them. That will define the solution that you will let's say pick or run or design for your environment. And of course, it all goes down to how you want to plan on disaster recovery or high availability, or run consistency in your cluster. There's like specifically we talk about databases. There are some databases that are more built for the availability or making sure that the data is more consistent. And there's some databases that are eventually consistent. There's different like metrics there when you pick up your data related solution. So that's on the CAP theorem. So this is like the how you balance consistency and availability and partitioning in your environment. The right side of the slide, or the left, I don't know if how you see that on Zoom. It talks about how you meet consensus, or the concept of consensus is how you make sure that in a distributed system or a distributed environment, all nodes are agreeing or making sure that they're all in line to the same data. And this is very important in databases specifically. But in essence, I just want to talk about the concept of Raft for a couple of minutes. Raft is it's like a kind of a protocol. This is like the leading protocol right now. And Paxos is just a mutation of Raft. It's based on Raft as well. And you can look at it in a very simple way that has leaders and followers. So this is like the bottom down of Raft. You have in all of your cluster, let's say you have a 10 node. Doesn't matter if it's a database or not. It could be any data related workload. And you have your nodes, and these nodes need to give an answer to a specific question, right? So in essence, Raft talked about the allocation of leaders and followers, and then if you ask a question for a specific follower, it will make sure you got the right consensus in the environment. And it talks also about how leader election is actually done. There's like a few metrics about it. Depends on latency or availability and so on, different metrics around that word about leader election. But in essence, all nodes talk to each other. There is a leader that is the final, or let's say it's the single source of truth. And there's different consensus mechanism in the back end. It can be, based on majority. It could be based on, the entire node network needs to, to be completely in sync before you give a specific answer. But in essence, this is how Raft is making sure that when you ask a specific question, you're getting the absolutely right answer, and not something that might be, not true, or true at a fraction of a second, for example. So this is, how data is kept consistency across nodes with this specifically, and there's a different kind of protocols and way of actually transferring this consensus between specific. So each product or each solution does it in a different way. There's like gossip protocols, which is like a chatter between the nodes. There's something that is more structured, whereas you have your primary and your secondary ones. And there's like different protocols that arbitrate or move this data around, or this consensus around the nodes. And this is just a high level, kind of, things that you need to keep in mind when you're picking a specific data workload. So if I go a bit higher in that stack, then we have our databases, which are like the major data consuming world. And we have a lot of like web, I don't know, like a lot of flavors out there. This is like the open source one in most of them. And of course, each cloud provider as well has its own flavor of this, let's say, open source solutions, where they do the maintenance and they do the upgrades and so on and so on. But in essence, these are the top. I think I got it from Docker Hub. Yeah, this is from Docker Hub. The images that are mostly downloaded for databases that are used, in the Kubernetes space. And of course, we have the commercial ones as well, which are the Oracle and the SQL, and also MySQL is Oracle one. But these are like the top players in this world. I want to touch briefly about, so running databases, as I mentioned, there's a lot of importance on data consistency, on availability, on scaling and managing them, and making sure that not only you're not only just throwing a pod with a database process running on it, you have to make sure that the entire database layer is synchronized and managed. And for this, specifically in the world of databases, it's a very, it's very key, or it's a very important to have an operator-led approach. Whereas, again, this is like a high-level 101 deck. I don't want to go too deep into what is an operator, but in essence, this is a way to make sure that, let's say, sensitive workloads and specific data is very, very sensitive. You cannot just, move around data without making sure that it's not corrupted or not consistent, and so on and so on. So an operator is a key and a most crucial component when you're running databases on top of Kubernetes. And in essence, I think there were a lot of sessions in the DoK about operators specifically for databases. So I'm not gonna try and compete with that. But in essence, the operator is there to make sure that this machine of database pods or database workloads are easily configured. A lot of tasks that are operational tasks are maintained within that operator. So if you want to scale, if you want to upgrade, if you want to change version, and if you want to, even have like advanced monitoring and have like specific best practices, you're getting that from that package, that database package. So there's like multiple providers out there for operators, and this is the right way to deploy, let's say, a production-wise or production-ready enterprise-grade databases on Kubernetes. I've tried, in the past, before the operator world was strong as it is today, I tried running databases, and every time you have to upgrade or change or move the workload, that could create corruption and problem in your data, in your database. So operators are, I think, they are de facto standard today. And this is, where you start when you're running databases of Kubernetes. But what's interesting, or even more interesting, is that the operator world is very, very similar to what you see in the cloud, or let's say the how would I call it, like the cloud native databases today, not Kubernetes container native, but cloud native. So if you want to run your, Aurora or DynamoDB or whatever, the service that they are bringing is very, very similar to what an operator actually brings. So they will bring you scaling, easy provisioning, some support metrics, best practices. They are very, very similar. And I think, and this is what we learned together with our customers, that because the cloud native database world came out a lot sooner than actually Kubernetes reached a maturity level, then a lot of customers, when they went to cloud, they went to these kind of services. So they went to the Redshift, Aurora or whatever, RDS for Postgres, for example, because that was the option to actually, that was the easiest option and the less costly means of operation option out there for them to just, offload and hand out their databases for somebody else to maintain. And now we're starting to see a lot of customers that are starting to, I don't want to say question that, but they are more open to, let's call it like a database as a service on top of Kubernetes, because the operators are getting to a very mature level where they are almost head to head with what the cloud providers are bringing. And then if you own the Kubernetes space and you have your operator that is almost the same as, let's say, what you're getting from the cloud provider, then this is like another barrier that has dropped down when customers want to or look at Kubernetes as a platform of choice. And then you get the benefits of Kubernetes, which is like, simple. You can do multi-cloud and the abstraction level of it, and you can run, whatever you want today on Google and tomorrow move to AWS, and there's no lock-in, and performance is something that you can maybe control easier. And there's a lot of visibility into that. And that's as I mentioned in the intro, this is like an interesting take that we see from customers today. And they are looking to, let's say, redesign or rethink the way that they do data on cloud and move it to data on Kubernetes. So this is a very important point. And as I mentioned, the database operator world is something that is very, 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 let's say, growing and getting stronger. This is just high-level operators that you have in the market today. For the top, this is like the top 3 that I could find. Most customers' conversation, they either use either one of these technologies. And there are very solid, stable, mature, operators that brings you most of these services on top of Kubernetes for these specific workloads. So the community of that is also very, very growing. But the point that I want to try and kind of, fold all the story to words is the fact that, this is just the databases side. And as we mentioned, Kubernetes is the platform for your entire workload. And sometimes, when you have, let's say, an enterprise application, it's not only a single database or database even technology. You have multiple databases, multiple data-oriented workloads that are running. Maybe it's Elasticsearch and CouchDB and Postgres and Mongo, all serving the same application. So sometimes you can get stuck with a lot of operators to actually, maintain and manage. And each operator has its own, let's say, expertise or its own language or its own way of thinking. So this is why, towards, closure again, I think that is very interesting, very important to try to think of, a joint kind of model where you can have your Kubernetes native data layer, which we talked about it, the basic, the infrastructure, managing the disk, managing resiliency, managing high availability on the infrastructure side, and connect that also to the higher level operators world. So when you take the good of both worlds, you can get a lot of benefits. Specifically, when we're talking about high availability and scaling in multi-cloud. These are the places where if you run only operator without, let's say, a very strong data platform below that, sometimes specific tasks like scaling can take a lot of time. Because if you can think about it, if I'm connecting both worlds, if you want to scale a specific database, you can see that online. In most cases, it's based on backup and restore of a specific volume. And if you have a very big database, that can take time. That can take there's a lot of extra work that you're doing. Maybe paying for a third-party kind of placement for your backups and so on and so on. But if you have a data platform that is on top of your nodes, you can do that with with cloning, for example, or you can move that between clusters, or you have high availability as part of your infrastructure. You don't have to invest and build high availability in each of the application levels that you have. You're getting a good enough, solid, high availability solution from your software development, the storage things, from the storage side of things. And that's it. Sorry, somebody just came in the room.
That's okay.
So you get
these things happen.
Yeah.
We're live.
Yeah, exactly.
It's all good.
Yeah. This is how we even though it's like 7 p.m. here, or almost 8, still people are running around the office. So just to close the things together, right? So when you want to run both of all these things together, you can get like high availability and resiliency out of your infrastructure instead of investing in replication and other data copy or data moving operations, let's say. So, and this is like the way that we like to think when we talk to our customers. They're saying, some basic things or some, some technology they would rather get from the infrastructure instead of the application level. And this is why it's important. This is why I started from top to bottom and from bottom up when I did this talk, because everything is like one unified story. There's no just one side of it. And this is how we see things. And of course, specifically databases enjoy that because they are, if your application needs data, then it has to be resilient. It has to be very clear for the application where the data is, and not pay for latency and some other things that can come out from unoptimized infrastructure or unoptimized deployments. That's about it. This is like the high level points that I mentioned in this talk. I really, if there are any questions, I'm more than happy to give my my answers or my view on things, let's say.
Yeah, I think it was the thing is, we've been around as a community for about 2 years, and I wish we had this presentation 2 years ago because it lays out these foundations in such a simple and practical way to approach it. What I would like to know is that when you're talking to customers, because a lot of what we try to explain is like, okay, in order for adoption of data on Kubernetes to increase, people inside organizations need to be better prepared about how to have these conversations. And with what you laid out, it makes everything very, very clear in terms of the advantages, where things are at now. As you said, operators are reaching a higher level of maturity than previously. But in terms of the doubts that you think are occurring in some companies, like, okay, Kubernetes, okay, but data is my mission critical, most valuable thing that I have as an organization. I'm going to keep that out because I don't want to be responsible if something goes wrong. That's one thing that we frequently hear. Is that something that you've encountered? And if yes, could you talk about that? And if not, if there are other things, what are the other kind of points of resistance or lingering doubts that you seem to see? Yeah,
so let's see. So I think that all the surveys and reports that we see, and also that we talk with customers, I think Kubernetes is, let's just start with a bad thing. It's still complex. There's a knowledge gap. There's still like pieces in the solution that is not 100% the most, even the other alternatives, even if you deployed an AWS in 2012, that wouldn't have been perfect, right? But I think the pace of new things that are coming into Kubernetes are making each gap that we see getting answered very, very quickly. The most pushback that we see from customers is either from operational side of things. This is why the operators are very important. So a lot of customers say, I'm running on RDS. I don't want to manage data. Data is complex. Data is it's something that is very like a wild beast and nobody wants to tame and nobody wants to work with. But we see that gradually changes because customers are understanding that how they did things like 4 or 5 years ago is not the way that they might have picked today. And there are solutions out there to make it easier to tame this data beast, for example. So mostly it's from the operational side. I think that the gap of actually running data or data workloads on Kubernetes is getting it's not, I won't say like a consensus, but it's getting less pushback. I think that we see, like we saw it in every other industry, we'll start with we talk about databases here today, but there's a ton of other data related workloads that are let's say more or less risky to put inside of Kubernetes. So those are already in most cases, and this is this is like the showtime, right? So I think in the next 2022 and 23, that's going to be the year of data on Kubernetes, because this is it. This is running. This is how customers are modernizing their infrastructure. We see that we see new workloads are cloud native, and cloud native is getting synonym to be Kubernetes, and the developers that are learning or learned the values of Kubernetes in the DevOps space, they want to get the same on their production environment. And this is the way that technology matures and moves from from dev test spaces towards and then one morning people say, why isn't it on Kubernetes, right? Why isn't it's what like in my previous talk, right? In like 10, 15 years ago, people would just woke up one morning and say, why is this workload not on VM, right? Why are we paying for a physical server? Why are we paying for all this operation, heavy lifting, and all this technology lock-in? And we'll see this history repeating. So people will wake up and say, why are we running this on, I don't want to, blackface anyone, but why are we running this on AWS? Why not on Google? Why not on, whatever local provider, cloud provider that is running in that specific country, for example? That's a trend as well. So we see Kubernetes is the interlink between all of these places. So I think this is like the way to go.
I agree. I couldn't agree more. And I think, like you said as well too, is that there have been other changes, in the past, and it's that these, transitions, people are resistant to change, and there's can be a lack of understanding. And also from a previous conversation I was having with someone today, the arrival of the stateful set a few years ago is sort of what started opening people's eyes to this possibility. And then from there, we've seen, more and more adoption and other ways of making it easier. So I think that's, like you said, I think it's well said.
And I think that maybe, I'm getting like kind of a mental note for myself here, because we talked about the KubeVirt world, which is something that is also connecting between these and sometimes is mitigating that request. We see a lot of customers, or even in KubeCon, I think there's a lot of sessions that, customers decided to go that way because it allows them to run still the VMs as something that they know, just to replace the infrastructure to Kubernetes. So maybe that's a good next session to do, like Kubernetes with KubeVirt data on Kubernetes. That may be interesting as well.
That sounds good. Let's get that in the calendar, because like you said, like that's the trick here. And another thing you mentioned too is, talking about the workloads. Traditionally, we think about database and storage. Now we're starting to see analytics, streaming, machine learning, AI. These other things are also becoming part of the ecosystem, because the general feeling is, well, yeah, it's easier to have everything all in the same place. Let's find a way to make this work. And that's also reassuring to see the stack kind of, we can say, get higher, broader, whatever you want to say. But I think that's also promising in terms of adoption.
Yeah. And I think that the breadth of solution probably Google gonna you know, as you said, like extract and get smaller as we go and converge, and we're going to see like a few more leaders, you know, moving the market more. But this is what's interesting in our field, right? There's no like one vendor lock-in. This is how you do things. This is how you do mainframe. There's only like one provider, and that's it. There's multiple solutions. Each has its own advantages and disadvantages, and this is what moves the market.
Yep. I couldn't agree more. Anyway, well, Barak, this has been amazing. Is there anything else that we need to know in terms of Ionir news or things that's coming up or anything like that that's on the horizon?
Nothing special, or just we are here if you're interested to having more conversations. I'm also running you know, a product to be honest. So if you're a customer and you're willing to talk with us, we're very interested to hear about, you know, what your challenge is and how we can help you out with it. So always open for conversation. This is not, you know, even just, you know, not in a commercial way. This is not what interests me, but just learn how to, you know, think about solutions in, you know, for customers in the future.
Yep. Good to know. And like I said, very easy to find on our Slack, Twitter, etc., LinkedIn. All the stuff will be in there. So thank you very much. We need to start playing the next session about KubeVirt. That sounds like a good thing to get going.
Yeah.
And so anyway, thank you very much, Barak. Thank you everybody for joining. And we can always continue the conversation on Slack if you got any questions, comments, doubts, and we'll be talking soon. Okay.
Okay. Thanks everyone.
All right. Bye-bye. Take care.